Hey guys, and welcome back. Now, I bet many of you have seen questions like this before. They're getting quite common on the internet these days, but I wonder who's noticed that this is actually a simultaneous equations question. My name is Miss Danielson, and today we'll be going through our second lesson on solving simultaneous equations, where the equations may not necessarily have the same coefficients for one of the two variables. I hope you joined us for our previous lesson, an introductory lesson to solving simultaneous equations. If you haven't seen that lesson, I'll link it down in the description box for you below. But if you have seen it, let's get started. Even if you were with us for our introductory lesson, you're going to want to write the steps down. Remember, step 1 was to just label our equations 1 and 2. Step 2 is going to change in this case because it was just to check that both of the equations have either the same number of x's or the same number of y's. Now that means to look at the coefficients of the x terms, and here my coefficient is 2, where there my coefficient is 7, so they are not the same. Here my coefficient is 3, and there my coefficient is not 0, there's no 0 in front of this y, there's no number in front of this y at all, that means it's 1y. So no, I don't have the same number of x's, 2 compared with 7, and I don't have the same number of y's, 3 compared with 1. So there's an extension to step 2. If they're not the same, we need to find a common multiple of one of the variables by multiplying all terms on both sides of one or both of the equations. Now let's explain what that means. 2 and 7 are not the same number, but we could find a common multiple of 2 and 7. And in order to get the same coefficient for both of these equations, I would need to multiply equation 2 through by some value and multiply equation 1 through by a different value. So the coefficients of the x terms will be more difficult to match than the y terms. In order to match the coefficients of the y terms, here I've got 3, here I've got 1, I just need to multiply 1 times 3 and it will match the coefficient of the equation above. So we're going to multiply equation 2 through by 3 and leave equation 1 as it is. So showing my working, I'm labeling my working, I'm showing that this is not equation 2, this is equation 2 once I've multiplied it through by 3. So 3 times 7x is 21x, 3 times y is 3y, and 3 times negative 6, don't forget to multiply the whole thing through, is negative 18. So that's my step 2. Now I can see that equation 1 and 3 times equation 2 do have the same number of y's. We've got the same coefficient in front of our y term. So step 3, just like before, is to eliminate one of the variables, either x or y, by subtracting the two equations from one another. That's not subtracting equation 1 and equation 2. That's subtracting the two equations that we sorted out in step 2 that have the same coefficient for one of the variables. So I'm going to rewrite equation 1 underneath this. Lined up nicely, I can see that I've got the same number of y's. So let's go ahead and do that subtraction now. 3 times equation 2 minus equation 1, so I will label that. And I'll do 21x minus the 2x. That'll be 19x. And 3y minus 3y is how we manage to eliminate the y variable. And don't forget to also subtract the values on the right-hand side. Negative 18 minus 1 is negative 19. So we have 19x is equal to negative 19. This is not equation 1. This is not equation 2. This is 3 times equation 2 minus equation 1, which has left us with a single variable equation that we can solve. So step 4, let's solve that remaining equation to find that single unknown variable x. Get x on its own. The opposite of multiplying by 19 is dividing by 19. And negative 19 divided by 19 is negative 1. So x equals negative 1. Now don't think that you're finished there. Remember, we have to keep going. We've got half the answer. Let's put a box around it and continue on. Step 6. Substitute the value we found into either of the equations to find the other unknown value. So it's your choice which equation you're going to use. I'm going to use equation 1. So 2 times the x value plus 3y is equal to 1. If the x value is -1, we're doing 2 times -1 plus 3y should be 1. 2 times -1 is -2, so -2 plus 3y equals 1. If I want to find out what y is, I need to rearrange this equation to get y on its own. So y is being multiplied by 3 and then added to -2. If I subtract -2, that's the same thing as adding 2. So we've got 3y is equal to 1 plus 2. 1 plus 2 is 3. So the opposite of multiplying by 3 is dividing by 3. Y is equal to 3 divided by 3, which is 1. So I've got my x value, it's -1. I've got my y value, it's 1. I've got my two answers that belong together. However, we still need to check that we've got the correct answers that work for both equations. I just found the value of y using equation 1. So it's a good thing I've labeled that so I know which equations I've used. So I should check if those answers are correct by using equation 2. So equation 2, if x is equal to -1 and y is equal to 1, will 7x plus y be equal to -6? Substitute those values in. 7 times the x value is -1 plus the y value is 1. Does that make -6? Well, 7 times -1 is -7. And -7 plus 1, is that -6? Yes, it is. Once the left side is equal to the right side, we know that we've got the correct values. And be careful, your answer's not -6. Our answer's already got a box around it up here. The x value is -1 and the y value is 1. When we substitute those values into either of equation 2, which we've just seen, or equation 1, which we used to solve this, we do get the correct answer. Let's just quickly go through those steps again before we go into some practice. Step 1 is still the same, labeling your equations 1 and 2. Step 2, make sure that both equations have either the same number of x's or the same number of y's. If they're not, we'll use multiplication and make sure you multiply all terms on both sides of the equation. Step 3, eliminate one of the variables, either x or y, by subtracting the two equations from each other. That's the two equations where we got matching coefficients for one of the variables. Step 4, solve the remaining equation to find the single unknown variable. Step 5, not really a step of working, but still an important step. You found half your answer, put a box around it, and let's keep going on to step 6. Step 6, substitute the value you found into either of the equations. Make sure you label that equation so you know which one you've used. And find the other unknown variable. Step 7, once you've got your two variable answers, check your answers using the equation that you have not yet used. If you used equation 1 in step 6, we'll use equation 2 to check. If you used equation 2 in step 6, we'll use equation 1 to check. So make sure you've got those steps down. Have another look over the example if you need to before we go on to the practice. Here you've got 9 different examples. Each of the examples involves two equations because these are simultaneous equations with a missing x and y value. So you need to find the x and y value that work for both equations at the same time, simultaneously. You should now be able to solve any type of question because if the coefficients of the variables do not match, you can make them match using multiplication. So go ahead and hit pause now, copy these questions out, label your equations and show how you're working. Don't forget to do your check and make your answers very clear, and push play when you're ready to take it up. I hope you had a chance to hit pause because here come your answers. For the first question, we don't have the same number of x's or y's, so you needed to match them first. And I would recommend multiplying the second equation by 2 to get your y's the same. Once you got your y's the same, you should have been able to eliminate them and find that x is 43, and then use that to find that y is -63. For the second question, again, I would have matched the y's. I think that would have been easier to multiply the first equation by 2. Once you got the same number of y's, you can eliminate the y's, and you should have found that x is -1 And using that -1 for x, you should find that y is -2. For the third question, be careful because the first equation's got -y. If I just multiply that by 3, I'll get -3 and +3 as my coefficients for y's. So be careful with the signs here. If you did this correctly, you should have been able to work out that x is 3 and y is -2. Let me know down in the comments section if you had any problems there. For the fourth question, we could get the y's the same by multiplying the second equation by 2. If you've done that, you managed to eliminate the y's and you'll have worked out that x is 3 and y is 2. For question 5, you should be able to get the same coefficient for the x's by multiplying the second equation by 5. Once you got the same number of x's, we can eliminate the x's, and you should have found that y is -2. And using y is equal to -2, you should have found that x is equal to 6. In question 6, very similar to question 3, if you just try to multiply the second equation by 2, you won't have the same coefficient for your y's. The first equation would have 2y, while 2 times your second equation would be -2y. So be careful with that. Maybe you matched your x's, or maybe you matched your y's by multiplying the second equation by -2. Either way, you should have worked out that x is 5 and y is 3. For question 7, it might be easier to match your x's here. We could easily multiply the second equation through by 4 to get 8x. If you did that, you could eliminate your x's and you should find that y is equal to 1, and then use y is equal to 1 to find your x value. X should be 3. For question 8, you should be able to match your x values quite easily by multiplying the first equation through by 2. Once you match your x values, you should be able to eliminate them, and you'll find that y is equal to 0. Using y equals 0, you should find that x is equal to -1. Finally, for question 9, you can match the coefficients for your x terms by multiplying the first equation through by 5. Once you've matched your x terms, you can eliminate them, and you'll find that y is equal to 0. Once you've found that y equals 0, you will have also found that x also equals 0. So that might have been a tricky question for you. How did that go? Having done your checks, I hope there's no surprises here, but if there are, please let me know about them down in the comments section so I can help you out with them. If not, well done. But keep an eye out for our next lesson where we'll be solving simultaneous equations again, but we'll be focusing on our positive and negative signs and the difficulties they can give us, much like in questions 3 and 6 that we saw here today. Now, before I let you go for the day, let's have another look at that question we saw at the beginning. Can you set up the simultaneous equations and solve them to find the value of a drink and a hamburger? There are actually 4 equations here. So let's set up the 4 equations shown. For the first one, let's use D to represent the drinks and H to represent the hamburgers. So I've got 3 D's added together, and I've got a hamburger, and together that should make 14. For question 2, watch out for that minus sign. I've got 1 drink plus 1 hamburger minus a hamburger plus a drink, and that should be equal to 10. For question 3, I've got 3 drinks added together minus a hamburger, and that gives me 16. And for equation 4, I've got a hamburger minus a hamburger minus a drink plus a hamburger, and that gives me -6. So you've got 2 unknown values here, the value of a drink and the value of a hamburger, but you've got 4 hints to help you figure out what those are. So you've got more than enough information here. Let's see who can work this out. Till next time, keep practicing and I'll see you soon.